Okay, now this problem is actually a little bit more straightforward than some of the others. We're asked to find the electric field between two parallel infinite sheets of charge. So you can draw two very long sheets of charge. And the top one has a particular charge density, 650 nanocoulombs per square meter. The bottom one also has a charge density that's positive. Sigma 2 is equal to 200 nanocoulombs per square meter. The question is, what's the field in the region between them? Well, we can use the fact that the electric field for an infinite sheet of charge is just sigma over 2 epsilon naught. Note that the magnitude doesn't depend upon the distance away from the sheet. So if I just go to any point in the interior here, it's always going to have the same electric field. It'll be constant. We just need to find that magnitude. Now we do have to remember, however, that electric fields are vectors. For this upward sheet, the E field always points outward. That meant if we were above the sheet, the E field will point outward, but we're not. Our observation is actually between the sheets. So the electric field from the top sheet points downward, away from the sheet, away from the positive charge. Okay, well that's fine. What way does the electric field from the bottom sheet point? Well, that sheet's also positively charged. And so electric field is actually going to point away from the bottom sheet as well. Away from the sheet, that is. So what we find is that the electric field from the top sheet is pointing down. The electric field from the bottom sheet is pointing up. So if we want the magnitude of the electric field, that's going to be equal to the magnitude of E1 plus the magnitude of E2 when these things are added up in a vector sense. The magnitude of E then is just going to be E1 minus E2. Okay, we can calculate this explicitly, but notice we had to do the vector addition carefully in order to get the proper result. Okay, the E field, magnitude of the E field in between the sheets, then is just going to be, well, the expression for the E field, if we go back up, is just sigma over 2 epsilon naught. So I just have to put in the numbers. The E field 1 is going to be 650 times 10 to the minus 9 coulombs per square meter over 2 times epsilon naught. Okay, so there's the expression for the top sheet. Let's get the expression for the bottom sheet. We subtract it because the vectors go in different directions. 200 nanocoulombs times over 2 times constant epsilon naught, 8.85 times 10 to the minus 12 coulomb squared per square. Okay, so we have the two fields. Now we just need to put in the numbers and solve. The magnitude of the E field, therefore, winds up being 2.54 times 10 to the 4 newtons per coulomb.